Hello, my dear students. Today we are going to start our discussion in chapter 2, which is chemical analysis. We are going to discuss the different fields in which we use chemical analysis. We are going to discuss the qualitative analysis. We are going to discuss the identification of acidic radicals. We are going to start with the group of hydrochloric acid. So let us start. Chemical analysis. Chemical analysis can be used in different fields. In medicine, the diagnosis of disease depends on the chemical analysis to estimate the percentage of sugar, albumin, uremia, and the cholesterol and others, or estimate the amount of the effective substance in medicine. In agriculture, it improves the properties of the soil in terms of its acidity and basicity and the agreement of soil in the agriculture of crops. Determination of the type of the properties of the elements in the soil to decide the use of the suitable fertilizer. In industry, the chemical analysis helps in determination of concentration and ratio of the raw materials and products that verify the standard specification. In environment, determination of harmful environmental pollutants in water and food. Also determination of pollutant materials in air such as carbon monoxide, sulfur dioxide, and the nitrogen oxides. The analytical chemistry. My dear students, we have to know the concept of analytical chemistry. It is the branch of the chemistry that deals with the methods and instruments used for both qualitative identification and the quantitative determination of the substance. So we have to know what do we mean by qualitative analysis. It is the identification of the constituents of the substance, if it is pure or mixture. What about quantitative analysis? It is the determination of the ratio or the percentage of the constituents of the sample. Now we are going to discuss in details the qualitative analysis. The pure substance can be identified through its physical properties as melting point. The identification of constituents of the mixture occurs after separation of the constituents, then detecting them through the chemical methods. Now, my dear students, we are going to discuss the types of qualitative analysis. The analysis of organic compounds, which is the identification of the organic compound through detecting the elements and functional groups in it. And the analysis of inorganic compounds, it is the identification of the cations and the anions forming it, which we are going to discuss in chapter 2. Now we are going to discuss the analysis of inorganic compounds. The detection of anions or acidic radicals. The identification of anions is divided into 3 groups depending on the reagent used. Today we are going to discuss the anions of dilute hydrochloric acid. It includes the following anions: carbonate CO3 negative 2, bicarbonate HCO3 negative 1, sulfite SO3 negative 2, sulfide S negative 2, thiosulfate S2O3 negative 2, and nitrite NO2 negative 1. So we have give reason in this point. The hydrochloric acid is used to detect the above anions. The reason for that because the hydrochloric acid is more stable than the acids of these anions. So when it reacts with their salts, it releases their less stable acids in the form of gas that can be detected by suitable test. Remember, my dear student, the stability of acids means the boiling point of acids. The acid that more stable has higher boiling point, while the acid which is less stable has lower boiling point. While the strength of acids means the strong acid that completely ionized in water, while the weak acid that partially ionized in water. Now, my dear students, we are going to discuss the first anion, which is carbonate. The main test for it is unknown solid salt plus dilute hydrochloric acid. The produced gas and its test. It causes effervescence during the evolution of carbon dioxide gas. As the equation proceeds on the screen, sodium carbonate plus hydrochloric acid, which is dilute, giving, according to double substitution reaction, sodium chloride and releasing H2CO3 acid that decompose into carbon dioxide and water, as the following animation show. Here, if you look at the screen, my dear student, on adding dilute hydrochloric acid on the sodium carbonate, carbon dioxide gas is produced, causing effervescence. And here, on collecting the carbon dioxide gas over lime water, as shown on the screen, it turbid the lime water due to formation of calcium carbonate. That when passing the carbon dioxide for a long time, it will disappear as it forms calcium bicarbonate. So, my dear student, as I told you, carbon dioxide turbid lime water. Here, carbon dioxide reacts with lime water, which is calcium hydroxide, forming calcium carbonate, which is wide percepted, that causes turbidity of lime water. That turbidity disappears by adding excess carbon dioxide gas on long time, as the insoluble calcium carbonate is converted to soluble calcium bicarbonate, which is CaHCO3O2. Now we are going to discuss the confirmatory test. Here, the salt solution plus magnesium sulfate solution, the produced percepted is wide percepted of magnesium carbonate that formed in cold. As the equation proceeds on the screen, sodium carbonate Na2CO3 reacts with magnesium sulfate, giving sodium sulfate Na2SO4, and magnesium carbonate is percepted, which is white percepted, as the following animation show. Here, my dear student, as shown on the screen, on adding magnesium sulfate solution over the salt solution, it gives white percepted that formed on cold. So, my dear student, that magnesium carbonate, which is soluble in dilute hydrochloric acid, as the equation proceeds, MgCO3 plus HCl, it gives magnesium chloride and carbon dioxide and water. So, the white percepted produced here can be dissolved in dilute hydrochloric acid. My dear student, notice that most of carbonates are insoluble in water, except carbonates of sodium, potassium, and ammonium, while all of them are soluble in acids. Also, notice that all bicarbonates are soluble in water. Now, we are going to discuss the second anion, which is bicarbonate. So, we are going to discuss the main test first, which is unknown solid salt plus dilute hydrochloric acid. The produced gas is carbon dioxide gas that causes effervescence. As the equation proceeds on the screen, sodium bicarbonate plus hydrochloric acid gives sodium chloride and the carbon dioxide gas and water. and so carbon dioxide turbid the lime water. Here, as shown on the screen, on adding the hydrochloric acid on the sodium bicarbonate, it gives carbon dioxide gas causing effervescence that happens in the tube, and so carbon dioxide gas passed on lime water make it turbid, that on pass for long time it will disappear due to formation of calcium bicarbonate, as done with the carbonate anion. So my dear student, the carbon dioxide gas produced from the reaction of the hydrochloric acid with the carbonate, the bicarbonate salt, it reacts with lime water, which is calcium hydroxide, giving calcium carbonate, which is wide percepted, and this turbidity due to a wide percepted of calcium carbonate disappears by adding excess carbon dioxide on long time, as the insoluble calcium carbonate is converted into soluble calcium bicarbonate that has chemical formula CaHCO3O2. Now we are going to discuss the confirmatory test of bicarbonate radical, which is the salt solution plus magnesium sulfate solution. As shown on the screen, the produced percepted, which is wide percepted, of magnesium carbonate is formed after heating. As the reaction proceeds on the screen, NaHCO3 plus MgSO4 gives Na2SO4 plus MgHCO3. This magnesium bicarbonate, by heating, gives magnesium carbonate, and carbon dioxide gas produced and water is produced. So the animation will show the reaction. Now, on adding the magnesium sulfate solution on the bicarbonate salt, it doesn't give any percepted, but by heating the carbonate is formed, which is insoluble, so the wide percepted appear after heating. Now, my dear students, we are going to discuss the next anion, which is sulfite. My dear students, we discussed the identification of carbonate and bicarbonate. Now we are going to discuss the identification of sulfite radical, as its symbol shown on the screen, SO3 negative 2. So we are going to discuss the main test first. The unknown solid salt plus dilute hydrochloric acid, the produced gas here will be sulfur dioxide gas, which has irritating smell and turns a paper wet with potassium dichromate acidified by sulfuric acid from orange to green. As the equation proceeds on the screen, Na2SO3 plus 2HCl gives 2NaCl plus SO2 gas plus water, as the following animation will show. Here, on adding dilute hydrochloric acid on the sulfite salt, the sulfur dioxide gas that is given out that reacts with the potassium dichromate that acidified by sulfuric acid, changing it from its orange color into green color as shown on the screen. Here, my dear student, the equation of the reaction of potassium dichromate with sulfur dioxide here is shown on the screen. K2Cr2O7 that acidified by sulfuric acid plus H2SO4 plus sulfur dioxide gas. Here the reaction gives potassium sulfate and chromium sulfate, and water is produced. Now, my dear student, we are going to discuss the confirmatory test. Here the salt solution plus silver nitrate solution, the produced percepted here is white percepted of silver sulfite, which turns black by heating. Here, my dear student, the sodium sulfite, when it reacts with silver nitrate, double substitution reaction occurs, so giving sodium nitrate and the silver sulfite that is formed, which is white percepted, as shown in the following animation. Here, on adding the silver nitrate solution on the sulfide salt solution, it gives white precipitate. Now, my dear students, we are going to discuss the next anion in the group of hydrochloric acid, which is sulfide, that has the symbol shown on the screen as -2. Now we are going also to discuss the main test, which is the unknown solid salt plus dilute hydrochloric acid. Here the produced gas here is hydrogen sulfide gas, which has bad smell, and it blackens a paper wet with lead acetate. As the following equation proceed, sodium sulfide plus dilute hydrochloric acid, it gives sodium chloride and hydrogen sulfide gas. This hydrogen sulfide gas, when reacts with lead acetate, it gives the acetic acid and black precipitate of lead sulfide. Now we are going to discuss the confirmatory test of the sulfide ion. The salt solution plus silver nitrate solution. The produced precipitate here is black precipitate of silver sulfide. As the equation proceeds on the screen, sodium sulfide plus silver nitrate, it gives sodium nitrate and silver sulfide. Remember, my dear student, it is double substitution reaction, where the silver sulfide is formed the only solid in this equation. The next anion, my dear student, which is the thiosulfate radical, here has chemical symbol as shown on the screen, C2O3 -2. The main test for it is the unknown solid salt plus dilute hydrochloric acid. As shown on the screen, the produced gas and its test, it gives sulfur dioxide gas, which has irritating smell, and also yellow precipitate of suspended sulfur is formed. As the equation proceeds on the screen, Na2S2O3 plus 2HCl gives NaCl and sulfur dioxide gas and water, as the following animation show. My dear student, if you look at the screen, here we add the dilute hydrochloric acid on the thiosulfate salt. It forms yellow precipitate of sulfur, which is suspended in the solution, and sulfur dioxide gas is given out. Now, my dear students, we are going to discuss the confirmatory test. Here, the salt solution plus iodine solution. Here, the observation, it removes the brown color of the iodine. As the equation proceeds on the screen, Na2S2O3 plus I2, it gives Na2S4O6 plus 2NaI. Here, the sodium tetrathionate is formed. Now, my dear students, we are going to discuss the last anion in this group, which is nitrite ion. Here, nitrite ion has chemical symbol NO2 -1, as shown on the screen. The main test for nitrite: the unknown solid salt plus dilute hydrochloric acid. The produced gas here is nitric oxide gas, which is colorless gas and turns into reddish brown fumes at the mouth of the tube. As the equation proceeds on the screen, NaNO2 plus HCl, it gives NaCl plus HNO2. Then HNO2 decomposed into HNO3 and 2NO plus H2O. Then NO combined with oxygen gas, nitric oxide combined with oxygen gas, forming the reddish brown fumes NO2, as the following animation will show. Now, the reaction takes place, giving the reddish brown fumes of nitrogen dioxide gas. Now we are going to discuss the confirmatory test. The salt solution plus potassium permanganate solution acidified with sulfuric acid. The observation here, the violet color of potassium permanganate disappears. As the equation proceeds on the screen, 5NaNO2 plus 2KMNO4 plus 3H2SO4, concentrated acid here, 5NaNO3 and K2SO4 and M2MnSO4 plus 3H2O are produced, as the following animation show. Here, my dear students, we are going to add sulfuric acid on the potassium permanganate to make it acidified. Then we are going to identify the nitrite radical. So the salt solution of the nitrite radical, we are going to add it on the acidified potassium permanganate. Here we show that the violet color of the potassium permanganate is disappeared. Now, my dear students, we are going to discuss some questions. The first type of the question is choose the correct answer. The solid salt plus dilute hydrochloric acid gives reddish brown fumes at the mouth of the tube, which is nitrite or nitrite or nitrate or sulfite. If you think about it, yes, it will be nitrite. Next one. The solid salt plus dilute hydrochloric acid gives gas, turns paper wet with potassium dichromate acidified by sulfuric acid from orange to green. Is it sulfite or sulfate or nitrate or nitrite? Yes, the answer it will be sulfite. Next point. The salt solution plus potassium permanganate acidified by sulfuric acid decolorize the violet color of potassium permanganate. Is it sulfite or sulfate or nitrate or nitrite? Yes, the answer it will be nitrite. Next point. The solid salt plus dilute hydrochloric acid gives gas, turns paper wet with lead acetate into black. Is it nitrite or carbonate or sulfite or sulfide? If you think about it, yes, the answer it will be sulfide. Next point. Solid salt plus dilute hydrochloric acid gives yellow precipitate of suspended sulfur. Is it sulfide or sulfate or thiosulfate or sulfite? Yes, the answer it will be thiosulfate. Next point. Salt solution plus magnesium sulfate solution produce white precipitate on cold. Is it sulfite or carbonate or bicarbonate or nitrite? Yes, if you think about it, it will be carbonate. Next point. Salt solution plus silver nitrate solution produce white precipitate turns black by heating. Is it sulfide or sulfite or thiosulfate or nitrite radical? If you think about it, yes, it will be sulfite. Next point. Salt solution plus silver nitrate solution produce black precipitate. Is it sulfite radical or thiosulfate or nitrite or sulfide? Yes, the answer it will be sulfide. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today, and till we meet again, my best wishes for you.